Hello everyone, welcome back. In this video, we are going to learn another important concept in Java multithreading, that is daemon threads in Java. So we will see with a clear explanation and we will see some practical examples. Subscribe to the channel to keep learning and growing your Java skills. Now let's get started. So daemon threads in Java. So imagine you start a background thread that is supposed to keep running, okay? But it is performing its task normally, there is no error, no exception. But as soon as the main work of your application finishes, the JVM shutdowns, even though that background thread has not completed. Okay, so you imagine like this is some background thread, which is running. Okay, and some main applications related threads are working. Okay, main application means other main application threads are running. Okay, so once this thread terminates or finishes its work and JVM shuts down. Okay, so the background thread has not completed yet, still it is in progress, but this one is completed. This is completed, but this is in progress. Okay, but JVM shuts down. JVM does not wait for the background thread to finish. JVM will only wait for these main application threads. So why did not Java wait for background thread? So the answer depends on one important difference. Was that thread a user thread or a daemon thread? That background thread was a user thread or a daemon thread. So in this video, we will understand the difference between user and daemon threads, and we will learn how setDaemon works and then create a practical background service example. And there is one more important rule about setDaemon that can throw an exception if you call it at the wrong time. So we will see exactly what that happens. Okay. So from the perspective of JVM shutdown behavior, threads can be classified as user thread and daemon threads. Okay, user thread and daemon threads. So user threads normally perform works. Okay, it performs primary application work that keeps JVM alive. And daemon threads typically provide background or supporting services. Okay, so the most important difference is not simply what kind of task they perform. The key difference is what happens when only daemon threads remain. Only daemon thread remain means only daemon thread is in under process and user thread is completed. So what will happen? So to understand that, let's first look at user threads. Okay, what are the user thread? So a user thread is a non-daemon thread. As long as at least one user thread, okay, one user thread is alive, the JVM normally continues running. JVM will continue running because one user thread is still active. Okay, so for example, suppose the main thread creates a worker thread. Okay, so this is worker thread. So main thread is creating a worker thread to perform some task. Okay, it can be any task. Even if the main method finishes, the JVM does not necessarily shut down. Okay, even if main method is terminated, JVM will not shut down. Why? Because worker thread is still in progress. Okay, so it can continue until the remaining user thread finishes. So a useful detail is that a newly created thread, this worker thread, inherits its daemon status from the thread, okay, that created it. So since the main thread is normally a user thread, and threads we directly create from the main are user threads by default. Okay, I hope you understood. So this is main thread. Main thread is what we call main method, right? So that is the main thread. And whatever threads we are creating inside main thread, that are user threads. Okay, user thread will perform some specific task. Okay, now we will see JVM shutdown rule. Okay, so this is the most important concept in the entire video. So daemon threads do not keep the JVM alive by themselves. Okay, so if all user threads, okay, let's say we have multiple user threads. Okay, so all user threads have finished and only daemon threads remain. So you think like there is one daemon thread and one user thread. So this is daemon threads and this is finished, completed, and this is in progress. Okay, so if all user threads have finished and only daemon thread is in progress, the JVM can begin its shutdown process. In such case, JVM will what? Start shutdown process. So it does not wait for daemon threads to finish their work. Okay, this means a daemon thread may stop abruptly or immediately when the JVM terminates. Okay, so once JVM terminated, daemon thread will stop immediately. So remember, user threads keep the application alive. If user thread, any of the user, even if one user thread is running, JVM will be alive. If all user thread have finished their work, JVM will start shutdown process. And once JVM exits, this daemon thread will be exited immediately. Okay, and that is exactly why the thread from our opening example suddenly stopped. Okay, now we will see the user thread and daemon thread comparison. So user threads usually perform the primary application work. Okay, primary work of an application. And as long as its user thread remains alive, it will keep JVM alive. And daemon thread are typically supporting or background work. It does not keep JVM alive. Okay, this is an important point. So if no user thread remains and daemon thread do not prevent the JVM from shutting down. So this difference is extremely important. Okay, deciding whether a particular task should run on a daemon thread or not. So based on our requirement that the task must finish, tasks have to finish, then we should inherit that task into the user thread. And for a particular task, we are not there is hard and fast rule to finish it, then we will use in daemon thread for that particular task. Okay, so if a task absolutely must finish before the application exits, okay, so we should use respective threads, appropriate threads. So it depends on totally on requirement, what kind of requirement we want. Okay, so this was user thread and daemon thread. Now there is a method called setDaemon to mark a thread as a daemon thread. Okay, how we will identify that this thread is a daemon thread? So we will use setDaemon as a true. See here in this line, we created one thread and we are marking that setDaemon as true. That means this thread will become now a daemon thread. Okay, so first step is to create the thread object. Second is to call setDaemon and only call the start method. Okay, so I mean to say, before calling start, we should call this method setDaemon true. before calling start, that means before starting thread execution, we should set daemon true. Okay, why does this order matter? Because once a thread has already started, we cannot change it to daemon status. Okay, so here is the rule I mentioned at the beginning of the video. Okay, so look at the code carefully. We create a thread. Okay, here we are creating a thread and we are starting it, and then we are trying to set the daemon as true. So after starting it, we are calling setDaemon true. Will this work? So the answer is no, it will not work. Why? Because a thread's daemon status must be set before the thread is started. Trying to change it after the thread is started will result in illegal thread state exception. So always remember the order. Create the thread, okay, then do the daemon status true, and after that start it. Okay, that is the sequence. And there is another method. So we can check whether a thread is a daemon thread. Okay, using which method? isDaemon method. So this is the method we can call whether it is a daemon thread or not. It will return boolean value. If it is a daemon thread, it will return true, or else it will return false. Okay, so this helps us to see how daemon status works when new threads are created. Okay, so this is one important method. Now there is another useful detail about daemon threads. Okay, so a newly created thread, inherits its daemon status from the thread that it's create. Okay, imagine like you have one thread. Okay, you have one thread, and inside this thread you are creating another thread, and this one is daemon thread. So a newly created thread will inherit all its daemon status from the thread from where it created. Okay, so if that daemon thread creates another thread, okay, you imagine like daemon thread is creating another thread, that new thread will also be a daemon by default. Okay, so child thread will also be a daemon thread by default. So similarly, a thread created by a user thread will normally be a user thread. Okay, unless we explicitly change its daemon status before starting it by calling setDaemon true. So this is why understanding who creates a thread can also matter when debugging a thread behavior. Okay, now let's understand daemon threads with practical conceptual example. So imagine an application with a background autosave helper. Okay, so the main application performs the important user facing work. Okay, so meanwhile a background thread periodically performs supporting tasks such as saving temporary state. Okay, so we may not want this background helper by itself. Okay, but to keep the entire JVM alive after all primary application work is ended. Okay, so supporting behavior. Okay, so that kind of supporting behavior can be conceptual use case for the daemon thread, but there is an important warning. Critical data should not depend on daemon thread. Always remember, critical data should not depend on the daemon thread. Okay, because daemon threads can be terminated when no user thread is alive. So we know the sequence, right? User thread, if even one user thread is alive, then JVM will be running. If all user threads are terminated or finished, then JVM will start its termination process, and all daemon threads will be closed immediately. That's why we should not use daemon thread for the that support that important critical data. Okay, because daemon threads can be terminated when no user thread remains alive. Now we will see for what kind of cases daemon threads are suitable. Okay, so daemon threads are suitable for, okay, like background monitoring, these things. Okay, so when might we consider using daemon threads? So they are useful for supporting background services. Okay, background monitoring, supporting cleanup activities, periodic statistics, background housekeeping, or non-critical supporting services. Why non-critical? Because it can be terminated immediately when JVM is terminated. Okay, so should this task alone keep the JVM alive? This is the question, key question. So before applying any task to daemon thread, we should ask this question. Okay, otherwise, if answer is no, then daemon thread is inappropriate. We should apply that task to the user thread. Okay, so for example, if the work is critical and most completely reliable, then we should use it in user thread. Okay, so you need proper lifecycle and shutdown management rather than simply relying on a daemon thread. Okay, so on what cases we should not rely on daemon threads? So daemon threads should not be relied upon for work that absolutely must complete before the JVM exits. So we should not use daemon thread for kind of work in which it should be finished before JVM exits. So for this kind of work, we should not use daemon threads. Okay. So for example, imagine a daemon thread is halfway through an important file write or critical data operation. If all user thread finishes, you should not assume the JVM will wait for that daemon thread to complete its critical work. For critical work, applications should use proper coordination and shutdown mechanisms. Okay, so the key idea is simple. Daemon threads are useful for supporting work. Do not depend on their natural completion for critical application. Okay, for critical data, critical things, critical operation, we should always use user thread. Okay, so now we will see the difference between the user thread and the daemon threads. So user thread keeps JVM alive. Okay, and daemon thread does not keep JVM alive alone. Okay, so once all user thread are terminated, JVM will start its termination process, and when JVM is terminated, all daemon thread will be stopped immediately. Okay, and user thread is mainly used for critical data required work, primarily required work. Okay, and it is for like supporting or background kind of work. Okay, so whenever we create a thread, default is user thread, and if we want to make this thread as daemon, we will call it setDaemon true, then that thread will become daemon thread. Okay, and JVM will wait for the user thread to finish, whereas for daemon thread, once all user thread has ended, JVM will exit and it will not wait for the daemon thread. Okay, so these are like major difference between the user thread and daemon thread. Okay, now if you remember only one rule from this video, remember this: ask whether any user threads are still alive. If user threads remains, then JVM will alive. Okay, if user thread is existing, JVM will alive. If no user thread is left, means all user thread are completed their task, only daemon thread is remaining. In that case, JVM will start its shutdown process. And when JVM will exit, then all daemon thread will be terminated immediately. Okay, so that's how it works in the background. Now So far we have been manually created a thread objects, right? And starting those threads by ourselves by calling a start method, right? So that works for learning the fundamentals. But imagine a server receiving 10,000 tasks. So we simply create 10,000 new threads. So imagine creating and managing a large number of threads manually can become expensive and difficult to control. Okay. So what if we could create a controlled set of reusable worker thread? So imagine like you have reusable worker threads. So we have different worker threads. This is kind of reusable. We have 10,000 tasks. Okay. And these are reusable threads. What is meant by reusable? That means these 4 threads will continue completing the task, and once let's say 100 tasks is divided into these 4 threads and 100 tasks is completed, then again they will pick another 100 tasks, and likewise they will reuse this thread for completing 10,000 tasks. Okay, so we could create a controlled set of reusable worker threads and simply submit tasks to these worker threads. So that is exactly what thread pools and Java's executor framework are designed to help us. Okay, and that changes the way we manage concurrency in real Java applications. Okay, so we will see this thing in next video. So that's all for this video. I hope you now have a clear understanding of the daemon and user thread. Thanks for watching, and I will see you in the next video.